With the next question, we have the function defined by f of x is square root of 1 plus 6x, and we're asked to find the domain and the range of f. Well, a square root function, a radical function, is defined only where the radicand is greater than or equal to 0. So we simply need to solve for 1 plus 6x is greater than or equal to 0, and that would give us x is greater than or equal to negative 1/6. For the range, if you recall that the square root of x, the parent function here, has a range that goes from 0 to positive infinity. And since we're not shifting this horizontally, vertically rather, at all, the range will remain 0 to positive infinity. And I'll write that in interval notation, although I could write it as y greater than or equal to 0. For part B then, we want to determine the slope of the line tangent to the graph of f at x equals 4, and all that's asking for is f prime of 4. So to do that, we need to find the derivative and then substitute x equals 4. So before I start, I might want to simplify the function, rewriting square root of 1 plus 6x as 1 plus 6x to the 1/2 power. And from there, we're going to take the derivative. So it is a chain rule. We have an outside function, which is something to the 1/2 power. We bring down the 1/2, leave the inside alone, reduce the exponent by 1, which gives us 1/2 of quantity 1 plus 6x to the negative 1/2 power. Now we still need to multiply that by the derivative of the inside function being 1 plus 6x, and its derivative would just be 6. And so f prime of x would be 3 times the quantity 1 plus 6x to the negative 1/2, or 3 over the square root of 1 plus 6x. And so f prime of 4 would then be 3 over the square root of 25 when we plug in 4 for x, and that simplifies to 3/5. For part C, we want to determine the y-intercept of the line tangent to the graph of f at x equals 4. So obviously, we need to find the equation of that line at x equals 4. So we have the x value, the y value, we need to plug in x equals 4, and we would get square root of 25, which is 5. So we have the x-coordinate is 4, y-coordinate is 5, and the slope is 3/5. In point slope form, that would be y minus 5 is equal to 3/5 x minus 4. But we're looking for the y-intercept, so we do have to put this into slope-intercept form in this case. And so before simplifying, we would get y is equal to 3/5 x minus 12/5 plus 25/5. So the equation of the line would be y equals 3/5 x plus 13/5, and the y-intercept would be 13/5. Okay, we'll go on to part D. In part D, we want to give the coordinates of the point on the graph of f where the tangent line is parallel to y equals x plus 2. And since the slope of that line is 1, we want to find all places where the derivative is equal to 1. So we go back up to the derivative, which is 3 over the square root of 1 plus 6x. We set that equal to 1, cross multiply, and we would get square root of 1 plus 6x is equal to 3. To solve this, you have to go back to pre-calculus and algebra 2. We solve this by squaring both sides, and 1 plus 6x is equal to 9, or 6x is equal to 8. So x is equal to 8/6, or 4/3. Now we still need to plug that in to make sure that it's a valid solution. So we go back to the derivative, plug in 4/3, and we get 3 over the square root of 1 plus 8, which is square root of 9, which is 3/3, which is 1. And so the derivative, when x is equal to 4/3, the derivative will be 1. And so we just state our final answer, f prime of x is 1 when x is equal to 4/3. And that will solve this particular part of the problem.